So we're going to go over example 2 now from section 1.3. And this is involving solving using the square root property. And you can see on the top we have the general square root property that says if we have something squared on one side of the equation, in this case we have x squared, but that x can be really anything. It could be any expression being squared, as we'll see in part B. And if that is equal to a numerical value, we'll just say c, then x is equal to the square root of c, or x is equal to negative square root of c. So there's a positive and negative solution. So we can also say x is equal to plus or minus square root c. So let's just understand why there are two solutions by going over a very simple example. So let's look at, let's go over x squared equals 9. So let's think about what we can square to get a solution of 9. And to think of this, we would think about what we can square to get 9. We can see that we can square 3, and that's equal to 9. We can also see that if we have negative 3 and we were to square that, that is also equal to 9. So there's two solutions. There's a positive 3. So in this case, we can see that x is equal to positive 3, because notice that we're plugging in 3 and negative 3 in for x. So x can equal positive 3 and negative 3. But to write this in the correct form, realize that 3 is equal to the square root of 9. So we can see that, that 3 is equal to the square root of 9 and the negative square root of 9, because negative 3 is equal to negative square root of 9. So that's like the square root of c and negative square root of c. And another way of writing this is x is equal to plus or minus the square root of 9. Obviously, the most simplified solution for this basic example is 3 and negative 3. But we can see that the square root property holds. That if we have x squared is equal to 9, then x is equal to plus or minus square root of 9. And that's what this square root property is telling us. All right, so let's go into, now that we can see the square root property works, the procedure works, we can tackle example 2. All right, so realize that to use this property, we must have the entire left side of the equation being some value squared. So we need to get that thing that's being squared by itself. So part A has some work to do. So notice that only the x is being squared. As you can see right here, the x is being squared. The 3 is not being squared, and the 12 is not being squared. So those parts of the left side of the equation have to move on to the right side of the equation. So sometimes there's a little bit of preliminary work. So in part A, the first thing we want to do to be able to move the 3 and 12 to the right side of the equation is to subtract the 12. So we'll do that to both sides of the equation. And that will give us 3x squared is equal to negative 12. Okay, so this will allow us to now divide by 3 to give us the x squared by itself on the left side of the equation. So negative 12 divided by 3 is negative 4. Now notice that we are in the form x squared is equal to c. So something being squared is equal to, and now our c value is just negative 4, because that's what's on the right side of the equation at this point. Now, if we want to get x by itself, we have to take the square root of negative 4. That's what this is saying right here. X is equal to square root of c, and x is equal to negative square root of c. Oh, well, we also need the negative solution. So we could say, or x is equal to the negative square root of negative 4. So notice the negative is outside the square root. So just because there's a negative here doesn't mean that we have our negative solution. The negative has to be on the outside of the square root. So this is what we have. Now, if we were going to continue with this problem, so we still have a little bit of work to do here. We're not done yet because we can simplify the -4 a bit. So back when we were studying complex numbers, we know that we can simplify the square root of -4 to x equals 2i, and then we could also say or x equals, now this solution would be negative, and then square root of -4 is 2i. So if you need a little bit of a review over complex numbers, please review where we studied complex numbers in chapter P. But you'll see that this would be the solution. We have the positive, the 2i, and the negative 2i. So another way of expressing this is, I'll write it up here. It would be x equals plus or minus 2i. That's like the plus or minus square root of c. And that's our final two solutions of this equation. And as always, you can plug it back into the original equation and see if they check out. All right, so let's move on to the next part. Now, as I mentioned before, x can be any algebraic expression. It doesn't mention this in the procedure, but realize that I'm telling you now, x can be any. So the part that's being squared in this procedure that they mention here can be any algebraic expression. So in this case, we have x plus 1 squared equals 48. Okay, so realize that x plus 1 squared, the x plus 1 is being squared. All of that is being squared. So in this case, we're ready to take the square root at this very moment. So we can say that x plus 1 is equal to plus or minus the square root of 48. We could have separated it to x plus 1 equals square root of 48 and x plus 1 equals negative square root of 48. But I'm going to combine them at the very beginning here. So just to let you know, you can do that as mentioned in this property here. So I'm going directly to this step. And then we can simplify this a bit. We're not really emphasizing how to simplify like the square root of 48 really in this class too much. You're not going to be dealing with that too much. So just realize that this will simplify a bit. And so I'll just write x plus 1 equals plus or minus. And so the square root of 48 actually simplifies to 4 square root 3. Again, we're not really focusing on that too much in this class. But yeah, trust me on that. And if you have any questions about it and you want to know, please reach out to me, feel free. Anyways, there's still one more step to complete because we're solving for x. We need to subtract 1 on both sides of the equation, and that gives us x equals negative 1 plus or minus 4 root 3. And again, since another way of expressing this, and I'll write it down now, x equals negative 1 plus 4 root 3. And we could also write negative 1 and then the minus solution, 4 root 3. So we have two different solutions. All right, there they are. Let me know if you have any concerns. I'll be more than happy to help.